L-2, IUPAC and common names of hydrocarbon substituents. These are the substituents derived from hydrocarbons by removing one or more hydrogens. Hydrocarbons contain only carbon and hydrogen. Alkyl or alkenyl groups. Here IUPAC nomenclature, CN is common name, IN is IUPAC name, PIN is preferred IUPAC name. In the nomenclature of organic compounds, we use sometimes common name or sometimes we use IUPAC name. Coming to alkyl or alkenyl groups, they are derived by removing one hydrogen from parent alkane. This is methane, CH4 methane. When one hydrogen is removed, the group or substituent is called methyl, or in short is written Me. This is both common name and IUPAC name. This is called ethane molecule. When one hydrogen is removed from ethane, we get CH3CH2, or we write condensed unit C2H5. This substituent is called ethyl. This is both common and IUPAC name. Sometimes it is simply represented by writing ET. Here it is propane, CH3, CH2, CH3. If primary hydrogen is removed, which is present on primary carbon, then CH3, CH2, CH2 called N-propyl, which is common name as well as IUPAC name, or it is called propanyl, which is preferred IUPAC name. Therefore, please note that a substituent or a molecule may have more than one IUPAC name. When hydrogen from secondary carbon is removed, then CH3, CH, CH3, through this carbon, this group can be connected with other carbon atoms. This is called isopropyl, which is common name and IUPAC name. Propane 2YL, this is preferred IUPAC name, or it is also called 1-methyl ethyl. For example, if you give numbering 1, 2 and 3, there are total 3 carbons. We use word prop, ane, and this carbon is connected through the second carbon, so we call 2YL. The other way of IUPAC naming is, let us call this carbon 1 and this carbon 2. The carbon which is connected to other group or carbon, let us label 1 and other carbon is 2. On the first carbon, we have methyl group, so we call methyl present on first carbon 1-methyl ethyl substituent. In short, N-propyl group is written as N-propyl and isopropyl group is written as IPR. Now let us consider N-butane, which is common name. We can remove hydrogen from primary carbon or from secondary carbon. When hydrogen from primary carbon is removed, then it produces CH3, CH2, 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 which is called N-butyl, which is both common name and IUPAC name, or we call it butanyl, which is preferred IUPAC name. We may call it butane 1YL, but if YL is on first carbon, we can ignore writing 1. When secondary hydrogen is removed, then it gives CH3, CH, CH2, CH3. Here through this carbon, it is connected with other atom or group of atoms. This is called secondary butyl group, which is common name as well IUPAC name. This is also called but. There are 4 carbons. But, it is connecting through second carbon N2YL, which is preferred IUPAC name, or it can also be called on first carbon there is a methyl group 1-methyl propanyl. 1-methyl propanyl. Now consider isobutane. CH3, CH, CH3, CH3. Here it is a primary carbon, it is a tertiary carbon. Removing hydrogen from primary carbon gives CH3, CH, CH3, CH2, which is also called isobutyl, which is common name and as well IUPAC name. This is also called 1, 2, 3, 2-methyl propyl, which is IUPAC name. This is also called 2-methyl propanyl, preferred IUPAC name. Here again we are not writing and 1YL. If 1 is there, it is not required. When tertiary hydrogen is removed, then the group CH3, C, CH3, CH3 is formed, which is called tertiary butyl, which is common name as well IUPAC name. So if you give numbering 1 and 2, on first carbon there are 2 methyl groups 2, 2 dimethyl ethyl, which is IUPAC name, or we give numbering as 1, 2 and 3. On second carbon there is methyl group, it is called 2-methyl propane 2YL, propane 2YL, because through second carbon it is can be connected to other atoms. This is preferred IUPAC name. Apart from alkyl substituents, we can have alkynyl or alkynyl groups derived from alkenes and alkanes respectively. Consider ethene, or we call it ethylene, common name. Ethene is IUPAC name. If one of these hydrogens are removed, then we get CH2 double bond CH, which is called vinyl group. It is common name as well IUPAC name. There are 2 carbons, therefore eth, as there is carbon-carbon double bond, ene, as it is connected to, can be connected to other group, we call it YL, ethynyl, which is preferred IUPAC name. CH2 double bond CH, CH2, called propene, IUPAC name, or it is also called propylene, which is common name. When this hydrogen is removed, then CH2 double bond CH, CH2. This group is called allyl substituent, which is both common name as well as IUPAC name. This can also be called prop, because there are 3 carbons. 2-ene, the double bond is present after the second carbon. YL, as it is first carbon through which it is connected to other substituent, we simply write YL. Prop 2-enyl, it is preferred IUPAC name. Ethyne, CH, triple bond CH, IUPAC name, or acetylene. This is a common name. If this hydrogen is removed, we get a group called eth, as there is a triple bond, ine, as it is substituent YL, ethynyl, which is IUPAC name. Now this is called propyne. CH triple bond C CH3. If this hydrogen is removed, it gives CH triple bond C CH2. Common name propargyl and IUPAC name prop 2 wine IL propanyl prop 2 vinyl 1 2 and 3. The triple bond is after the second carbon. This is called benzene. When one hydrogen is removed from benzene, it gives phenyl, which is both common name as well as IUPAC name. The presence of phenyl group sometimes we represent in the molecule by simply writing pH. Let us take an example question. Write the compound that is obtained by combining allyl and propargyl. Also find hybridization states of all carbon atoms. CH2 double bond CH2 is allyl group. C triple bond CH2 is propargyl group. When allyl and propargyl are connected, then we get this compound. To write hybridization, if carbon forms 4 sigma bonds, it is sp3. If carbon forms 3 sigma bond and 1 pi bond, sp2. If carbon forms 2 sigma bond and 2 pi bonds, it is sp hybridized. Now, by writing the structural formula of the carbon, this carbon is forming 1, 2, 3, 3 sigma bonds and y pi bond, 1 pi bond, it is sp2. Similarly, this carbon 3 sigma bonds and 1 pi bond, sp2. This carbon is forming all sigma bonds, 4 sigma bonds, so sp3. This carbon is also forming 4 sigma bonds, sp3. This carbon is forming 2 sigma bonds and 2 pi bonds. Therefore, it is sp. This carbon is forming 2 sigma bonds and 2 pi bonds. Therefore, sp hybrid